Hello everyone. Welcome back to the DSA for Beginner series. In the previous video, we learned what is a tree, terminologies such as root, parent, child, leaf nodes. Along with that, we learned height of the tree, depth of the tree, and we saw an example for binary trees. So today, we are going to learn one of the most important topics in our trees, which is tree traversals. So traversal simply means visiting every node of the tree exactly once in a specific order. Tree traversals are asked in almost every coding interview question because they form a foundation of many advanced tree problems. So let's get started. Let's take a simple example. Let's take one. So why do we need traversals? Suppose we want to print all nodes, or we have to search for a value, or serialize a tree, or calculate some sum, or finding a height of the tree. So, to achieve all of this, we need a systematic way to visit every node, or else, while we are traversing, we might get lost if we don't have a systematic way. So we have different types of traversals. One is DFS, which is depth first search. So basically, we go into the depth first of each nodes. So we have multiple traversal techniques in depth first search, and we have one more which is called breadth first search. Basically, we go via breadth of the nodes. So I'll explain how it will happen. First, let's first see what are the types of depth first search. So we have pre-order traversal, we have in-order traversal, we have post-order traversal in depth first search. And if we come to breadth first search, we have level order traversal. So let's see our example here. So let's say I will go into the depth of each node. So if you see, the arrow mark is going to the depth of the tree. So if you want to know more about depth of the video, refer my last video. So there I have mentioned what is the depth of the tree and details of that. So you see this arrow mark, right? So it goes into the depth of the nodes. So that is why we call it as a depth first search. So let's see how breadth first search works. So in our breadth first search, right? So the traversal happens at each level. So basically, if the arrow mark goes at each level, then that is called breadth first search. Let's see how this depth first search works. Okay, so we'll go one by one. First is pre-order traversal. Pre-order traversal. So if you see in our tree, too. So basically, pre-order means root, left, and right. So this is the order which is followed in pre-order. So basically, we print this, we visit this node, then left node, and again right node. So let's take a bigger tree as an example. So that way we can understand better. So here, what depth first search means? Go into the depth of the tree. So what is the uh, notation for the pre-order, which is root, left, and right. So 1, and then what is the left of this? 2, and then again left of this 4, then right of the second root node. This is 5, and then right of the this node, which is 3, left and right. I hope you understood. So basically, first root, then left, root, left, and again left, and then right. It comes back, then right, left, and then right. So this is how pre-order traversal works. So let's see a code snippet of how we can achieve this. Or we can take couple of more examples. So let's say I have 3, 4, 5, and 6. So let's see how this works. So here, what is the notation? So if you see, root, left, and right. So 1, this is the root, then go to the left of the node, 2, again left of the node, 4, again left of the node, 6. So since there is no right, we'll go back and then go back. So here we have the right of the node, 5, then go back, it's already visited, then 3. So this is how pre-order travels happens. So how are we going to achieve this programmatically? So let's see that. So if you see, so this can be achieved in recursive way, because in recursion what happens? Each method is called again and again. So let's see the code. Recursive. So here, if you see, public void the order of, let's take node as root. If root not equal to null, then we do visit the node, which is print out the node, root dot value. So again, if you have missed my previous video, just go and watch. We will know what this notation and all. So we do a pre-order call again, which is a recursive call dot left. And then we do pre-order of root dot right. So again, we'll close this. So how does this work? Let's see this with this example. Okay. So here, when we have the first call, so initially root is not equal to null, root dot value. So 1 is printed, and then next call, pre-order of root of next. It goes to second. So again, this method will be called. Again, root not equal to null. So 2 will be printed. Again, second call. Then root, fourth one. Fourth node, this node is printed. Again, root printed. Then sixth. So again, this root will be, next is null. So it will come back, return. Then it goes to right of it. Here there is no right. So here there is no right. So It will go back to second node. Then it will print the, it will call the right node again. So here it goes to fifth node. After that, again call back. Then it goes back to 1 and then it goes to right side of the node. Then third node will be printed. So this is how a recursive, code for the pre-order. So let's clean this up. Okay, our next traversal technique. So which is in-order traversal. So how does that work? So here in-order traversal notation is left, root, and right. So basically the flow goes like this: left, root, left, root, and then right. So basically in order will be 2, 1, and 3. So let's take a bigger example. So how are we going to represent this? 4, 5, 6, 7. So if you see our notation, left, root, and right. The leftmost node is 4, root is 2, and then right is 5. Again, this portion of the node is completed, which is the left part, and then it goes to right, which is 1. Then it goes to right. Here we have left 6, then goes to node, root node, then again right. Sorry, this is 7. Okay, so this is how in-order traversal is done. Let's see simple how this in-order is done in our recursive code. So let's take public void. Okay, so this is our recursive code to do a in-order traversal. So if you see, we are doing root not equal to null and then call the same in-order method again. So what it does is, the first time whenever the root comes here, it will go to left of this node. Again, if we again this will be called. Again second root. Again the left of this is called. So root 4 is there. Then again, so when it reaches the root node 4, right? So it sees there is no left to this node. That is when it starts printing the value. So 4 is printed. Again, the next call, right? So this is the next call, which is node of in order of right. So this is called again. So again it goes back here. So again 2 will be printed. Then it goes to the right of the node. Same goes here. It comes to here and then the control goes back to first node, then right. So here, once it comes here, it will go back to left, 6, and then root, and then right. So this is how recursive code for a in-order traversal. So next we will see post-order traversal. Okay, so let's see how post-order traversal works. So for post-order traversal, right? So the notation for post-order traversal is left, right, and then root. So basically, so the root of the node is visited at the end of the traversal. So basically, First, we visit 4, which is left of the leftmost node of the tree, then goes to right, and then it goes to root of it. So 4, 5. So if you see, if you want to understand the simple flow, it goes like this: left, root, and right. So 4, 5, 2. Again, this is completed. Now it goes to right side of the node. So here 6. So here it goes like this: 6, 7, 3, and then this is the root of the node, last node. Okay. So let's see the traversal. How can we achieve this using a Java program? So here, okay. So let's see how this recursion works. Okay. So initially, when the root comes, so it will call the left of the subtree, left of the tree. Then again it goes to left of the tree. So here there is no more left. So that is when, okay. So let's see how the recursion stack is there for this post order. So initially post order of 1 is called. So this will call post order of, because we are doing a left root dot left. So that is when post order 2 is called. Then post order 3, 4 is called. That is when left of the subtree is called. So after this, it will call post order of null. So what are we doing here? So we are only printing if root not equal to null. So it will not do anything for the left of the tree. Again, the control goes to next line, which is post order of right. Again, it is a post order of null. So that is when the control comes to the printing line. So that is when 4 is printed. Again, it goes back. So if you remember, this will go back. This will go back to root of post order of 2. So that is when it will call. So here in the post order 2, so it came back here. So you remember, right? Post order of left is called. So that is when 4 came. Next line is what? Root dot right. So that is when it goes to node 5. So once it goes to node 5, so again it will call. So here if you see, so post order of 2 will have post order of 4. It came back. Again we have to do post order of 5. So this will call again post order of null, post order of null. Sorry, post order of null. It comes back again, it will print the 5. Now the control comes back to the root. So this part is completed. Now again go to the right of the tree. So here left first, and then right 7, and then 3. Then at the end of the recursive call, it goes back to the root of the node. I hope it is clear. Okay, so what all techniques we learned today? We learned pre-order, notation, root, left, and right. Root, left, and right. We have in order, which is left, root, and right. So we have post order, where left, right, and root. One interview question which can be asked here is when we have a binary search tree. So binary search tree. In order can be used as a sorted order. This can be asked in a interview question. So let's summarize what all we learned today. We learned how what are the traversal techniques. We saw DFS, BFS. In DFS, we have in order, post order, and pre order. In our next video, we'll see uh, BFS technique, which is level order traversal. So basically, we travel trees across breadth of the tree, and then we'll maybe solve a couple of lead code questions. See you tomorrow. Happy coding.